Dear students, in this session we shall discuss about the temperature controller circuit. In this circuit, the key element is thermistor. Here, NTC or negative temperature coefficient thermistor will be used to describe the circuitry function. The thermistor is thermal resistor and its resistance is dependent on the temperature. NTC means negative temperature coefficient. In this discussion, we shall use NTC thermistor with its room temperature resistance 100 ohm. This is the circuitry for the calibration of the thermistor. That is, with respect to the temperature, how the resistance as well as what is the potential drop across the thermistor is developed. Here we have used 12 volt main supply DC with 10 kilo ohm resistance in series. Follow the cursor. That is, in this path almost 1 milliampere current is flowing. So when the temperature of the water bath, which is controlled by a heater, immersion heater, which is not shown in the figure, and when the temperature will increase, that temperature will be catched by the thermometer, and accordingly the potential drop across the thermometer will be checked by the millivolt meter attached here. Here I am trying to show the demo data which was taken during the increasing and the decreasing of the temperature of the water bath, and check when the temperature is around 28 degree, almost the room temperature, the potential drop across the thermistor is 109 MV. And when the temperature it increases up to 91 or 90 degree, the PD decreases in a consistent way and it reaches to 15 millivolt. If during the cooling we check, more or less the same pattern we get. So what is the key role of this circuitry, what we are going to discuss? That is, the water bath, it has a particular temperature. If we can adjust the temperature of the water bath in a particular point, then the heater will be connected to some circuitry instead of the main plug, as well as the thermistor will be also immersed in the water bath. That is, it will supply the corresponding EMF in the circuitry, which will be checked by the circuitry, and accordingly the temperature of the water bath will be controlled at the fixed point by running the heater or by disconnecting the heater within the system. So here is the calibration curve what we have got from the temperature variation with respect to the millivolt. So when a particular temperature will be asked to make it constant, so from the calibration curve we can choose which temperature and accordingly which MV is required to fix in the circuit. So here is the main circuit. Just check as usual. Here is that 10 kilo ohm what I have attached earlier plus 12 volt supply, and here is the thermistor. Vt is the potential drop at this point. Follow the cursor as shown in the figure. Follow the circuit. Here are the three parts. First part is composed of first op amp, second part is composed of second op amp, and the third part is composed of one transistor in CE mode. Now if we just think the circuit part by part, what are the three parts? Again I am showing it. It is the first part, it is the second part, and it is the third part. And Vt is the thermistor voltage. Now let us discuss about the first part. As we have seen, the thermistor voltage from the calibration data, so the value is very feeble, little bit. So we have to, firstly we have to magnify the value, that is we have to amplify. So this amplification will be done, or the magnification will be done by using the first op amp, which will act in non-inverting mode. So pin number 2 and pin number 3, pin number 2 is the inverting terminal, pin number 3 is non-inverting terminal. So in your practical book, I am again talking about the Big Hosh volume 2, what you generally the students in the Calcutta University, they use that book. So here one resistor was connected, but without attaching the resistor, the same thing can be done. So when Vt is the plus terminal, that is the non-inverting terminal, then using this R2 by R1 combination, we can have the expression of V out of the first op amp, that is VO1, as 1 by R2 by R1 into Vt. And this ratio we have taken as the almost 10. Remember, if we just take the ratio very much greater than 10, the op amp may reach the saturation point and your circuitry condition will not be satisfied. So what is your aim using the first part? Just to amplify the amount of Vt, that is 11 times of Vt, that VO1 we have got sufficiently large. Now about the second part. So this is the second part, that is after getting the VO1, we shall introduce a second op amp which is working in comparator mode. That is in the plus terminal, that is the non-inverting terminal, pin number 3, when VO1 is connected, that value will be checked by the point, follow the cursor, which is connected to the minus, that is pin number 2, inverting terminal. So if the potential drop at this point is greater or lesser than the VO1 as it is reaching the plus terminal, accordingly the output of the op amp will be judged. If the voltage at this point is higher than the voltage at the plus terminal, then it will reach in the negative saturation. If this voltage is lower than the potential at the plus terminal, then the op amp will reach the positive saturation. Now automatically the question arises, which value of RL and what is the function of the pot? That is, we shall change this pot in such a way so that we can decide, we can have that decision, that is whether it will be greater than VO1 or VO or less than VO1. So here is the, again I am showing that data of the calibration. Just check, the value is around 100 MV, that is the highest value of the potential for the thermistor at room temperature. So if I just apply this relation, that is as it is the series combination, the RL and the pot, and if I apply 1 kilo ohm pot here, 12 volt is the main battery supply. So this point, follow the cursor, it acts as the potential divider point, and if I consider the maximum, the safeguard, because the maximum potential what I have seen here, the 28 degree, it is around 100 MV. I am taking the safeguard 2000 MV, that is the 2 volt. I can have this relation 1 volt also, no problem. To the safeguard say 2 volt. Just to support your conception I have used in your practical book. So 12 volt into 1 kilo ohm by 1 kilo ohm plus RL, you know why it is happening, because of just the potential divided circuit conception. So this potential at this point, follow the cursor, it will be, if I consider 2 volt, then easily I can find the value of RL. So now, using the first part, using the second part, and using the third part is composed of the transistor in the C mode, and here is one RB is connected to the base terminal. Then our third attempt is how to calculate the RB. That is, after the comparison, either the op-amp is in the plus saturation or it is the minus saturation. So how I will decide about, or better to say, how the transistor will decide whether it will be on or off. So here the role of the transistor is it acts as switch, and it operates either in saturation or in cutoff. So again, the calculation I am trying to show, the calculation, it is the second op amp, then the RB. What the calculation? This collector terminal of the transistor is connected to the relay coil. The relay coil generally is around the 100 ohm. If we consider the value, we are not in the fault position. And IC set, that is to make the transistor in the full conducting mode, that is saturation condition. As we know, VC set generally it is under the 0.2 volt, and here follow the cursor, because this line is connected to the plus 12 volt. So 12 volt minus VCE, it is the rest potential drop across the relay coil. So 12 volt minus 0.2 volt divided by 100 ohm, it is 118 milliampere, the IC set. Now if we consider the beta of the transistor is the 200, then following the relation IB equal to IC by beta, we get IB as the 0.59 milliampere. Now it is the IB, the direction of the IB is from op amp output, that is the pin number 6 to the base terminal of the transistor. So IB, it goes to as 12 volt. Why it is 12 volt? Because when the transistor will be in the saturation, either plus or minus 12. So when the plus 12, then the transistor will be on. When the minus 12 saturation, the transistor will be off. So when it is a plus 12, then the IB mean it will be 12 minus 0.7. Why 0.7? Because follow this loop, you know the base emitter loop. When the transistor is on, VBE is 0.7 volt. Then correspondingly, you know the IB mean. So very uniquely, you can find the RB value. So here from this calculation, say the RB is around, it is, we are showing this a 19.15 kilo ohm. So if we have the several parts one by one, then the 3 parts are clear. So let us discuss the full circuit again. So it is my full circuit. So first part will amplify VT, second part will compare that VO1, whether it will be which potential I am fixing here following the calibration curve, and the third part will decide whether the relay will be connected to the heater or not. When the transistor is on, that is the fully it will be conducting the current, then the transistor is on the saturation mode, then the heater will be on. So remember, heater is now on not through the main plug directly, but through the circuitry. So after choosing a particular potential of the thermistor, say as we have seen in the calibration curve, then as per our choice for a particular temperature, the heater will be on, otherwise it will be off. So what are the statements, how the circuitry is just working? Let us judge again. First is, if the temperature of the water in the beaker increases, the temperature of the immersed thermistor will increase. Next, as temperature of the thermistor increases, the voltage drop across the thermistor decreases. So, Vt decreases. Therefore, VO1, that is the potential at non-inverting terminal of the second op-amp, it decreases. The potential at inverting terminal of the second op-amp dominates and it reaches to negative saturation. The base terminal of transistor gets reversed bias and transistor goes to cutoff condition and it stops conducting. The relay detaches the heater from heating and temperature decreases than the previous value. As temperature decreases, thermistor potential increases, resulting the second op-amp to reach positive saturation and transistor starts to conduct. The relay connects the heater to increase the temperature of the water. This procedure gets carried on in a cyclic order, keeping the temperature of the water bath at a fixed temperature. So in this way, we can develop our temperature controller circuit by using thermistor, op-amp, transistor and the relay and one immersion heater. So after this, I think it is little bit clear how we will proceed and how we can draw the circuit without seeing our book. So okay, have a good day. Goodbye.